Good morning to all my 78 stars, 76 stars. So, with a good note by our Mallikarjun Kurgod, let us start today's session on the other part of group 16th, sulfur dioxide. Yesterday, we were discussing we have to study in brief two important compounds of sulfur. One is sulfur dioxide and the other one is very more important than sulfur dioxide, that is sulfuric acid. Okay, right. So first we study in brief about the sulfur dioxide. So main important part of sulfur dioxide is its impact on the nature. Preparation part property is very easy, so it is impacting very badly on the nature, on the environment. So therefore that part we have to worry, you have to think concern about our nature. Okay, right. So this is our topic of discussion. What is then sulfur dioxide for 12th class? See here. Yeah, all this we have already studied yesterday. The ozone part before lockdown, after lockdown. Right. Sulfur dioxide. It is a binary compound. It is a chemical compound. It is an oxide. Okay, you can explain in a different way using your language, vocabulary, all those. Okay, so it is a binary compound of sulfur with oxygen, SO2. And the most important part is it is a toxic gas and with a pungent odor. We don't like, highly irritating. Whenever you heat any sulfate compounds in the laboratory, in the test tube, immediately you will get pungent smell and you don't like it. You start coughing or burning sensation to the eyes, nostrils. You don't, all those will happen. So it is highly toxic gas, especially its main part is it affects the lungs. Lungs are the most important part of our body. Okay, where oxygen intake, oxygen what out, exhale, inhale, that all mechanisms are there in the body. That part only is affected by the sulfur dioxide. So if you work continuously in the sulfur dioxide atmosphere, I think lungs cancer is guaranteed. Therefore, those who are working in the sulfur dioxide atmosphere, they are given high salary. First point, because their life is at risk. Second is they are given special aprons, special masks, so that it will filter the harmful chemicals. So that is all arrangements are made by the companies. So if they appoint in the field of what, sulfur dioxide plants. Okay, don't worry. So first class dress codes are available, first class masks are available. Okay, with high salary, with first class facilities. Right. So where it is available, sulfur dioxide? Sulfur dioxide is uh, wherever sulfur burns. See, sulfur we can burn from many areas. In the coal mines, so coal is a fossil fuel. So there some small amounts of sulfur is there. So whenever we burn coal, so sulfur dioxide is the one of the minor products. So all the coal industries, the one which is in the South India very famous, Neyveli. Okay, so that all they give out SO2. But now government has given some warning that any unwanted gas from industry is to be treated properly. So all that gas are sent to one chamber, where in that chamber it is treated and it is made neutral. Then it through other pipeline it is sent to the atmosphere. That is the SOP. How we follow SOP for the COVID-19. In the same way, for the factories also, especially for the harmful chemicals, government has made some SOP that they have to follow. Otherwise, that industry will be seized by the government. Okay, so all those precautions are there. So in this way, SO2 comes to the atmosphere, and by nature, wherever volcanoes are there, no, so there also SO2 comes. But volcano, how much? At the most, once in a year, twice in a year, that in a particular only one area where it is more prone to volcano. So whatever activity done by the nature is under control. So it is under control. But what we are doing, nearly 130 crore people in India only, in China, in America, the developed countries, what we say. So their work is beyond control. Okay, nature does once in a year, that will limit in limit. But we are limitless. Okay, so beyond limit, so we have crossed already limit. Certain metros are already in the danger zone. Already government has given the warning. So that there is a wing known as what? Uh, Environmental chemistry. It studies the samples of water and the air, and keep giving cautions. Okay, so wherever coal, what industries are there, where petroleum sources are there, so there we have the sulfur content. So in all these water, we get the sulfur dioxide. So let us control the evolution of sulfur dioxide. Otherwise, treat and send. Now it is used to preserve foods. Okay, so because sulfur dioxide is a very what pungent, so bacteria will not form fungus, algae, all those relate to the food chemistry. So food will not spoil. The main part is so it is passed and again it is treated. Then it is sent to the pot where it is required. So to preserve food, a small amount of SO2. But nowadays we don't use SO2. So there are variety of food preservatives are available with the CFTRI Mysore. So the separate wing is there, the CFTRI. So there they will give user friendly or human friendly preservatives so that food is preserved safely. Okay, right. So it is one of a group of sulfiting agent used in wine. Okay, on many dried fruits. Okay, excuse me, 1 minute. Excuse me, just a minute. Okay. So thank you for waiting for a few minutes. Sometimes we have to speak to some person who are on emergency line. Okay, they are called hotlines. Okay, anyway, so thank you very much. So I was explaining about what it is used as a food preservative. So used in wine industry. Wine you can use it because wine bottles are stored in one cans or container. So that is surrounded by the CO2 gas. So that is okay. Directly on the food, so it is not allowed. So for wine, it is okay. Right. So now methods to prepare sulfur dioxide. Okay, it is easy to prepare sulfur dioxide. So you take any sulfur content, whether it is sulfate, sulfite, or sulfide, or directly sulfur powder. Okay, so from all those methods, we can prepare easily what this sulfur dioxide. But in the laboratory, it is made use by the any sulfite, especially alkali material sulfides, which are very active, ionic. So either potassium or the sodium sulfite with the help of sulfuric acid. So you will get sulfite to sulfate, then SO2 comes out, and that SO2 is purified. Okay, so through the concentrated sulfuric acid, because some amount of water vapor will be associated normally with the SO2. It is because it has got affinity towards the water. So that's why to dry, we once again pass through the sulfuric acid, which acts as a dehydrating agent. It absorbs only water vapor, but not the sulfur dioxide. That is sent through another delivery tube, and it is collected in the gas jar by the method known as upward displacement of air. Because sulfur dioxide is heavier than air, we don't follow that method, downward displacement of water. Okay, so depend upon the nature, we change the method. So because it is heavier than air, so normal gas jar is kept in normal position, not a downward normal position. So when the SO2 gas goes inside, so it is heavy, no? So automatically the lighter air will come out. So it is automatic. It is automatic. Okay. Hmm. Right. So there is no need to do any additional arrangement. When the heavy comes, automatically light one will automatically go. Hmm? And how our if my senior friend comes and say that sir I want this, immediately will help like that. So when any heavy one comes, light will go automatically. So this is called the upward displacement of what air. Sulfur dioxide is collected in the laboratory, and then using a collection you can go for the study of properties. Okay. Now commercially, what is commercially on large scale? Okay, so on large scale you will go for any method. There is no special method. Randomly you can go for roasting. Roasting is a heating technique. Okay, just you how we roast in our house some curries or something in the same way. Even in the industry also, in the furnaces they roast by supplying heat days together, weeks together, or months together continuously 24 hours. So sulfides are converted into water, sulfur dioxide, and the sulfides, iron sulfide become either ferric oxide or ferrous oxide or ferric oxide. So that oxide is not important here. Okay, so let it form ferrous, ferric, or ferric. So SO2 comes out, that is collected. Okay, and if you want in the liquid form under the pressure, so it is converted into what, a liquid sulfur dioxide, because sometimes we use a liquid sulfur dioxide for some preparations. So how we use ozone water and H2S water, in the same way SO2 water is treated for the food industry and for some other organic chemicals preparation. That time it is required. Otherwise it is directly collected in the SO2, because SO2 gives a kind of a suffocative smell. No, that's why even in the industry also SO2 is converted into SO2 liquid. That will not give any suffocative smell, because it is in the liquid state. So it is not that much volatile. But SO2 being a gas, so by chance small escape is there, so it causes problem to the our lungs, especially suffocative area. Therefore, it is preserved safely as liquid in the containers or the cylinders. Okay, right. Otherwise, one more method is directly you collect the sulfur from the frost process, that is mining of sulfur, that is directly roasted or heated. So you get a sulfur dioxide. So any method you can follow. So methods are very easy. Now chemical properties of sulfur dioxide. It is an acidic, okay, non-metallic. Non-metallic oxides are acidic oxides. Okay, so that is readily dissolved in water. So when the sulfur dioxide dissolves in the water, H2SO3 sulfurous acid is formed. Okay, so because it turns the blue litmus red, so we can go for a litmus test also. So from that all those tests we can easily tell that it is an acidic oxide. So it reacts promptly with the sodium hydroxide solution and structures sodium sulfite. Oh, that is forms here. SO2 with NaOH gives Na2SO3 plus water. So in this way, so all these are very easy properties of sulfur dioxide. So let me remove this area so that I can see easily this part. I will come this. Okay, right. In the event that more sulfur dioxide is passed into this arrangement, sodium hydrogen sulfite is formed, not framed. Make it as a formed. Sometimes while typing F A are very close. So formed. So SO2 plus Na2SO3, that gives NaHSO3. Okay. So all these are different forms of sulfurs, sulfate, sulfite, hydrogen sulfide. So all those interconnections we can do it. Okay. So only thing is we have to be careful about the conditions and the contents also. Okay. And the sulfur particle in a sulfur dioxide atom is tetravalent. Okay. It is S double bond O double bond O. So all that is there. So it is what tetravalent. Four valence is 4. Already OS we studied. 4 and the 6 are the most common OS in the group 16th, and at the bottom, due to inert pair effect, as usual, s electrons are not busy in the bonding. Okay, all those. But if the sulfur goes for the higher OS, and as usual, what we studied in the past, so in the higher OS, normally compounds are covalent. Okay, because of the again Fossen's rule, again depends on the polarization. Okay, so higher charge will polarize the anion easily and goes for the sharing of electrons. That's why they become more covalent, but they are ionic. So ionic develops the more covalent character. Okay, So, and again, one more important compound of sulfur is there. It is called thionium chloride or thionyl chloride, okay, or sulfuryl chloride, SO2Cl2. Now, this is the most important reaction of chemistry under sulfur dioxide. Sulfur dioxide is converted into sulfur trioxide. If you use vanadium pentoxide, reaction becomes a bit fast. Otherwise, without also it forms. So this equation we use in what in the preparation of sulfuric acid. That's why this equation plays very important role. So the most important chemical property of sulfur dioxide is converting SO2 into SO3. Okay, right. So now SO2 is what? It undergoes some other reactions where it is what? Reducing Fe3 to Fe2 plus all those. These are the reduction reactions of what? SO2. All those. How to identify sulfur dioxide is there or not? Okay, by smell you can identify, but chemically, so it decolorizes acidified potassium permanganate. So whenever SO2 enters the KMNO4 purple color or the pink color, suddenly it becomes colorless. Okay. So why it becomes colorless? Because it is converting the KMNO4 into MnSO4. MnSO4 is white in color, colorless, whereas KMNO4 is the pink or the purple. So it is because of the reaction. So we find change in the color, and from this we can tell that it is SO2. Okay. So how we have done in the previous classes, how to see that whether from CO3 CO2 is coming or not. So that CO2 we pass in the lime water. If the lime water turns milky, that is carbon dioxide. In the same way, there are some tests in the laboratory on a small scale we carry out. So SO2 in KMNO4, if it decolorizes, it is SO2. So it turns filter paper moistened with the acidified K2CO2 solution green. This we will do in the laboratory. In 12th class it is there under the chapter salt analysis. Okay, so because we are heating certain sulfates in the laboratory in the test tube. So sulfate SO4 will give out SO2, and that SO2 we pass on the filter paper, which is dipped in the K2Cr2O7 potassium dichromate. So potassium dichromate acidified, and that filter paper is dipped into that bottle, and that is taken, and that is we bring near that wet K2Cr2O7 filter paper near the mouth where SO2 is coming. So immediately you see the green coloration. So that green coloration is because of what? Because of formation of chromium sulfate. So it is the green color of chromium sulfate forms on the surface of filter paper. That's why it looks green. So earlier it was orange color because potassium dichromate is a orange color. Okay, orange yellowish. So that becomes what? Now green. All these what? Due to the formation of a new product which have different color, different property. Okay. And third is what? It turns starch iodate paper blue. So that means what? You should bring the filter paper, dip in the KiO3. Okay. So potassium iodate. Okay. That this has come from the starch. A part of the starch from iodine we convert it. All those. So when the potassium iodate, you bring the filter paper, dip in that. That again is how already you have done in the K2Cr2O7 in the same way. We will do here also for the KiO3 potassium what iodate. That turns what? That turns blue. Either you can bring filter paper dipped in the K2Cr2O7 or dipped in the KiO3. So in the case of K2Cr2O7 it becomes green, whereas in the case of KiO3 it becomes the blue. So most of the iodine compounds they turn into blue because iodine color is what? It is violet or the blue color. That's why due to the formation of the iodine, so we will have the that blue to violet shade, blue to the violet shade. Okay, right. So now this one, structure of sulfur dioxide. So one side double bond, other side a single bond, or the using the resonance chapter of the 11th class, it is called what? Resonance hybrid structure for the sulfur dioxide with only one bond length, that is 143.1 picometers, and the bond angle is 119 degrees. Okay, right. So all these parameters using the knowledge of what? Chemical bonding. See the list of application uses sulfur dioxide uses in the assembling of sulfides, sulfuric acid and hydrogen sulfide. Assembling is what? A preparation. Excuse me. So in the preparation of many sulfur related compounds, SO2 is the starting material. It will assemble other chemicals in it so that other sulfur compounds are formed. And in the sugar business, for refining and decolorization, okay. So normally what we do, we do using the animal charcoal, that is the calcium phosphate. If by chance due to some reason, if animal charcoal is not available, or if you don't like the odor of the animal charcoal, which is highly unpleasant. So because if you store the animal charcoals in the sugar industry, so nobody likes to go near that area. Very unpleasant smell. Okay, so it is a rotten animal body smell. Hmm. So that time they go for the they pass a small amount of sulfur dioxide onto the brown colored sugar. Thereby it removes the color. Then again they go for the dissolution, filtration, refining, all those. Then white crystals of sugar is made and packed in the industry and sold in the market. So for decolorization or to refine the impurities from the sugar, SO2 plays very important role. So normally, once again I am repeating, animal charcoal is used. Only thing its availability and its odor. Except these two, SO2 is used. And third is what? For refining lamp oil or the other petroleum items. So there also some impurities may come whenever we take out the petroleum from the earth crust. Or lamp oil is what? It is a blackish in color. So that all we pass into the sulfur dioxide atmosphere. So thereby all the color impurities are absorbed. So leaving behind very crystal clear original color is brought to the petroleum products. So light color that is holding the water petroleum bunkers. Okay, right. Now as a disinfectant, same the main uses of SO2 what? Either to remove the color, to bleach, or to kill the microorganisms. Okay. So as a disinfectant, so in different forms. So sulfur forms what? Best skin, what I said in the beginning only. Uh, Most of the skin ointments are made up of what? Sulfur drugs. And as a fumigant, so a farmer or in the house or in the garden, okay. So if SO2 gas is sprayed, so no microorganisms will be there. But that time you should be very careful that no human beings are there. Okay. So because it also affects the human body. So keeping the all other side and using the mask by the one who is fumigating. So then it is fumigated. And after half an hour, 1 hour gap, we have to enter that area. Hmm? And that is for dyeing fragile articles. These are the articles which are made in the industry and they are sent to different parts of the uh, some for some museums they send. Okay, so that time they will just polish. They go for shining, and they will keep in the atmosphere SO2. So all free. So fresh articles are sent to the different parts of the museums. That's about dyeing the fragile articles. As anti-chlor means remove the color. Okay, so to absorb the chlorine, all those words are there. Anti-chlor, and to expel the over water abundance chlorine from substances those have been filled by chlorine. Okay, that means chlorine also is used as the bleaching agent. By chance if you use extra chlorine, that time that extra chlorine will give trouble. So that extra chlorine, to remove that extra chlorine, we pass SO2. So that SO2 will react with the chlorine, becomes SO2 Cl2, what we have seen in the chemical properties. So thereby extra chlorine is removed after the bleaching. So first we'll bleach by the chlorine. So after the bleaching, we go for the removal of the chlorine. So when once the work is over, so that time we go for the removal of the extra chemical which is left after the work. So as a glue, solvent means what? What is glue here? Glue is sticky like a gum. Okay, so SO2 is made into as a liquid solvent. In that some chemicals will dissolve. So they will become like a paste. So they will become like a paste. So that time it is used as a glue. And as a refrigerant in refrigerators, it was very old use. So now we don't use. Now we have the, because it is old use, so still it is there in the list. So because if you use SO2, so it's a problematic. So now this use is not there. Where the human beings are not there, When it is controlled by the machines or the robots, at that time we can use it as a refrigerant. Otherwise, normal freons are used as a coolant in the cooling systems. And as an additive for wines, this I told meat as a food preservatives. Okay, all those I already in the beginning only it is explained. Okay. Now we will come to the another important part of sulfur chapter, that is oxo acids of sulfur. Already we learnt oxo acids of what? Phosphorus. Where in the 15th group, now in the 16th we are learning oxo acids of sulfur. Okay, so let us study. And in that the most important oxo acid of sulfur is sulfuric acid. So we study only about sulfuric acid, not about any other acid. Okay, these are the oxo acids of sulfur. Directly I have taken from the textbook. So 1, 2, 3, 4. Sulfurous acid, H2SO3. Pyrosulfuric acid, okay, H2S2O7. Okay, it is called as oleum. Like, looks like a oil heavy. Okay, that's why it is called what? Oleum. So pyrosulfuric acid, it is heavier than sulfuric acid. And normal sulfuric acid, H2SO4. And peroxo disulfuric acid, where two units of sulfuric acid type they have combined, and a bridge is made. SOOS bridge is there. So because of that bridge, we call it as what? Peroxide. Because in the chemistry we have seen the peroxide linkage, hydrogen peroxide, HOOH. Okay, all those peroxide linkage we have seen. In the same way, due to the bridge, due to the peroxide linkage, so we call it as what? Peroxo disulfuric acid. So two sulfuric acid via peroxide linkage is known as peroxo disulfuric acid, H2S2O8. Okay. So among this, the most important is once again sulfuric acid, which is called what? King of chemicals. Why it is called king? Because its application is more. Okay. So its use is more. All the countries are using this chemical in one or the other way. Okay, so whatever we are progressing today, whether it is a plastic industry or any other industry, okay, so it is because of what? It is the sulfuric acid, either in its own form or in the different form or in the derivatives form. So sulfuric acid is made use in industry like anything. Okay, and a particular country's what per capita income depends upon how much the country or a nation is using sulfuric acid as a starting material to prepare some other chemicals for the development for the modern world. Okay, so that all is decided. They will calculate the income of the country. So that means imagine the income of the country is depending on the use of sulfuric acid. So that shows that sulfuric acid is very important chemical due to its multiple applications. That's why it is called what? King of all chemicals, and it is prepared on large scale by the process known as what? Contact process. Okay, that we study. So Aram say, but why it is called as the king of chemicals or the king of acid? Due to the use. Okay, so please go through this slide where I have written many uses. Okay, only one word I'll say. Already said, because of its multiple applications. But one important point I made it in bold. That is what? India produces about 48 lakh tons of this acid per year. 48 lakh tons. Imagine the huge amount of acid is prepared. So which is used, and also a sector graph is given, how much it is used in terms of percentage. So that all shows, this all data shows and give us supporting support that it is having many uses. Therefore it is called what? King of chemicals. Okay, right. So now we study how the water, the sulfuric acid is manufactured in the industry. When we know that it is a king of chemicals, it has got many uses. So then why to waste time? Let us study how it is prepared, how it is manufactured in the industry on large scale, which is known as what? Manufacture of sulfuric acid. Okay, right. So it is done by the method known as what? Contact process. Why the contact? There is no special meaning for this title. So here chemicals are contacting. Okay, so no special scientist has made. It is a teamwork. So therefore, just contact is a kind of combination. Okay, certain chemicals are made to contact, made to combine, and at a different levels, and ultimately we get a sulfuric acid. So for this reason, we are using contact, but no special meaning here. Okay, right. And the main raw material for sulfuric acid is what? Sulfur. Okay, so if you want sulfuric acid, first you bring the sulfur and convert it into what? Sulfur dioxide. So that sulfur dioxide is again converted into what? Sulfur trioxide. This I told, very important property of what?
Sir,
Sulfur. Huh? Yeah, please.
sir, sulfur is also related to acid rain, no, sir?
No, sulfur dioxide.
Oh,
Sulfur.
sulfur and sulfur dioxide are different.
Sulfur is a powder. It is element. When that
Okay, sir.
element converts into volcanic eruption SO2 or by human beings in industry, that is escapes the atmosphere. There SO2 becomes H2SO3 by the rain. That is called acid rain. Hmm?
Okay, sir.
So first recount is what? Sulfur, and second is what? Convert sulfur into sulfur dioxide, and third is convert sulfur dioxide into sulfur trioxide. This is the key reaction or the important reaction of the contact process. You will ask which is the key reaction in the manufacture of sulfuric acid. It is converting SO2 into SO3. Okay. So once SO3 is ready, because next step is immediately acid forms. So SO3 in water becomes H2SO4, or with some other method we can convert SO3 into easily H2SO4. So it is easy to convert SO3 into H2SO4. So therefore our first and the foremost hand in requirement is what? We want SO3. So that's why getting SO3 is very important. Therefore, that reaction is given importance. So in the examination also, that's the same thing. So key reaction, most important reaction, are the heart of the contact process. Okay. So all those different words they use in the question paper. So it is SO2 to SO3 using the what? Catalyst known as vanadium pentoxide. Okay. So in this way, at the end, we prepare sulfuric acid by the contact process, and it is collected and sent to the different parts where it is having used. So what today we will wind up 10 already over. So now tomorrow with once again in detail with the diagram, with the flow chart, we study how the sulfuric acid is manufactured uh, by using the contact process using diagram. Just have an idea, theory part. Okay, when you enter the industry, we learn exactly how it is made. So let us have an idea. So with this, I am winding today's session. So if at all any doubts are there, so please, I will wait for a few minutes. Then we will wind up. Hmm? It is only SO2 today. SO2, how it is made, what are its important properties, and how the SO2 is converted into SO3, so that the same reaction we make use in the sulfuric acid. Okay. So property part of SO2 becomes the preparation property, uh, preparation part of the sulfuric acid. Okay. So all these equations are interrelated. Hmm? So I think it is 10:11. We will wind up today's session, and tomorrow we go for the diagrammatic way of understanding water, preparation of sulfuric acid. So till then, have a nice time, and thank you, and all.
Thank you, sir.
Thank you very much.